to find the number of moles, then some numericals based on chemical equations. So these three we are going to discuss now. So first one is how to calculate molar mass. Second one is how to calculate number of moles of a substance, and numericals based on chemical reactions. So first of all, we'll see how to calculate the molar mass. This molar mass is nothing but relative molecular mass. Relative molecular mass. Molar mass of a compound or molar mass of any substance which contains molecules will be equal to its relative molecular mass in grams. So this is also called gram molecular weight. Gram molecular weight. Let's see an example. Example 1. Calculate the molar mass of sulfuric acid. Calculate the molar mass of sulfuric acid, that is H2SO4. Atomic weights of the elements: hydrogen 1, oxygen 16, sulfur 32. So this is the question. Calculate the molar mass of sulfuric acid. So here you are going to write the molecular formula of that substance, which is sulfuric acid here. So here you got two hydrogen atoms. So two hydrogen atoms into hydrogen's atomic weight 1. So 2 into 1 plus one sulfur atom. One sulfur atom is 32. So 1 into 32 plus 4 oxygen atoms are present in H2SO4. So 4 times atomic weight of oxygen, that is 16. So which equals to 2 plus 1 into 32, 32 plus 4 into 16, 64, which equals to 98 grams. Since we are calculating molar mass, so molar mass is taken in grams. So this is how we find the molar mass or relative molecular mass, which is also called gram molecular weight of a given substance. So you can practice for some other compounds in a similar way. You try this question. Calculate molar mass of copper sulfate if atomic weights are given like this: oxygen 16, sulfur 32, copper 64. So this is for your practice. That is for your practice. So second thing, how to calculate number of moles of a substance. Number of moles of a compound or a substance. we use this formula to find the number of moles of a substance. The given mass by molar mass of that substance. So mass will be given when we use the given mass. So given mass divided by molar mass. Let us see an example. How many moles are present in 32 grams of sulfur dioxide? Atomic weights are given like this: oxygen 16, sulfur 32 grams. So how to solve this? To find number of moles, so two things we are required, that is mass and molar mass. So the mass is given in the question, that is 32 grams of sulfur dioxide. So this is the given mass. So mass which is given is 32 grams. From this we can find molar mass. Molar mass of sulfur dioxide is equal to one sulfur atom. So one sulfur atom is 32 grams. So 1 into 32 plus 2 oxygen atoms we have. So 2 into atomic weight of oxygen 16. So 1 into 32, that is 32 plus 2 into 16, again 32. So this will be equal to 64 grams. So this is the molar mass of sulfur dioxide. Mass is given in the question and we have done the molar mass. Now number of moles of sulfur dioxide is equal to, so this is the formula we are going to use. Number of moles equals to mass by molar mass, which equals to mass is 32 grams divided by molar mass is 64. So this will be equal to 1 by 2, which equals to 0.5 moles. 0.5 moles means in 64 grams, that means in 32 grams of sulfur contains 0.5 moles. Next, and you try this question. This is your practice. What is the mass of 2.5 moles of sulfuric acid? So this is for your practice. What is the mass of 2.5 moles of sulfuric acid? So this is how we find number of moles, and if number of moles is there, we can find the mass of the given substance. Now, this number of moles can also be calculated from the given volume of a gas. So number of moles of a gas at STP is equal to right. So number of moles of the gas at STP is given by this formula. That is the volume of the gas which is given divided by molar mass. Molar volume. The molar volume of any gas at STP is equal to 22.4 liters. Molar mass of any gas at STP is equal to 22.4 liters. Let us see an example. How many moles are present in 5.6 liters of carbon dioxide? So for this question, we don't need any atomic weight, since in the formula we have number of moles of the gas equals to the given volume divided by molar volume. So the given volume, this is the volume given. So volume given will be equal to 5.6 liters. 5.6 liters. And molar volume is equals to 22.4 liters. Now we want number of moles. Number of moles present in carbon dioxide gas. So then the given volume is, this formula we are going to use. Formula is given volume by molar volume, which equals to the volume given is 5.6 divided by molar volume is 22.4, which is equals to 1 by 4, which equals to 0.25. So 0.25 moles are present in this. So this is how we find the number of moles from the mass and volume of a given gas. So next one, we have some questions based on the equations. Let us see a question like this. chemical equations. Questions based on the chemical equations. Let us take this question. Example 1. Under this, aluminium oxide on thermal decomposition, gives this is aluminium hydroxide. Aluminium hydroxide on thermal decomposition gives alumina and water. So this alumina is nothing but aluminium oxide, Al2O3. So this is the equation. AlOH thrice gives Al2O3 plus H2O. This is 2 times. This will be 3 times. If 54 grams of, let us say 27 grams of water is produced in this reaction, then calculate first one, mass of Al2O3 produced. So I am going to find mass of alumina, Al2O3, and number of moles of aluminium hydroxide taken. Number of moles of aluminium hydroxide taken. So first, what's given here? Along with this, atomic weights also will be given. Atomic weights: oxygen 16, hydrogen 1, aluminium 27. So this is the list of atomic weights of different elements, which we are going to be used in this numerical. Right. So here, what is given is 27 grams of water is produced. So that is the mass of water. So this is what given. 27 grams is given. And what are you asked to find? You are asked to find mass of alumina. You are supposed to find mass of alumina. So this will be written as X. So mass of what is 27 grams and mass of alumina you need to find. So what we do here is, so from the equation we can see that for 1 molecule of alumina you will get 3 molecules of water. For 1 mole of alumina you will get 3 moles of water. So this is 1 mole of alumina and these 3 moles of water. That means 1 into its molar mass and this 3 into molar mass of water. So we need the molar mass of alumina first. So 1 into molar mass of alumina. So 1 into molar mass of alumina. So 2 times aluminium. So aluminium is 27. So 2 times aluminium. 2 times 27 plus 3 times oxygen. Means 3 times 16. 3 times 16. And this is water. So this has to be written here. So 1 into 2 times aluminium plus 3 times 16. So this is for water. So here we have to take water. So water is 3 times. 3 times H2 means 3 times its molar mass. So 3 times H2, 2 hydrogen. So 2 into 1 plus 1 oxygen. So 16. Okay, so first we find what is this. So 2 ones are 2 plus 16, 18 means 3 into 18. 3 into 18. So instead of this, you can replace this with 3 into 18. And coming to this. So 1 into something is remains same. So that is just 2 into 27 plus 3 into 16. Now this is 2 into 27 is 54 plus 3 into 16 is 48. So the total will be 102. So we can replace this with 100. Now we need to find x. So cross multiply x into 3 into 18 which equals to 27 into 102. From here x equals to 27 into 108 and 102 by 3 into 18. So 3 table in this 9 times, 9 in this 2 times, 2 in this 51 times. So 51 grams. So 51 grams of alumina will be produced in this reaction. So this is the first bit. Okay, you can pause the video and you can note it down. Then we go to the next one. Second bit. Number of moles of aluminium hydroxide you need to find. Number of moles of aluminium hydroxide you have to find with comparison with mass of water H2. So from the equation, what can we take? From the equation we can take 2 times AlOH thrice. So here we need number of moles. So we just take this number of moles. So here molar mass is not required. Molar mass of aluminium hydroxide is not required. Then so this is related with mass of water. So from the equation, so we have to find number of moles here. So we take it as x, and the mass of water is given, that is 27 grams. 27 grams of water. Now from the equation, number of moles of aluminium hydroxide. From this equation, it represents these 2 moles. Will give you this much of water, means 3 times molar mass. Already we have done 3 times molar mass of water is 3 into 18. So directly cross multiply. So x into 3 into 18 which equals to 2 into 27, where x will be 2 into 27 by 3 into 18. So 3 table in this 9 times, 9 in this 2 times, 2 will cancel, we get 1. So here You are taking 1 mole of aluminum hydroxide for this preparation. Okay, I hope you understood how to calculate mole concept, numericals. We'll meet in the next class. Thank you.